models. They could be Barbie dolls, teddy bears, Claudia Schiffer. I'm going to really look into exactly what a model is and how we've used it. We use it for other people and eventually it uses us. So let's try and work out what a model is. And now a model is got a very specific term for it in science. So science, we definitely talk about scientific models, but indeed it's just a way a scientist would talk about a model. It's still the same thing. So you've got a real object, say for instance a kitten. That's a real kitten, and it requires a certain amount of eating. It's got it weighs a certain amount. It's fluffy. It definitely is a cat, and it remains a cat whether we watch it or not. Then there's the hooks we actually use to describe a kitten. Firstly, there's the word a kitten. There's probably a picture of a kitten. There's probably models or books about kittens. There's anything which we use which is a handle in our head to invoke the idea of kitten, so we can manipulate it. So rather than actually counting the number of kittens, weighing, I could weigh the amount of kittens in the world by actually get them all physically up on some scales, or I could use certain things like models to get through. So the word for a kitten is a model. The stuffed toy animal as a kitten is a model, and this is a great thing as we have, because once I have learnt about one kitten, that one kitten transfers to the model, and then the model transfers to the next kitten. So it allows me to, when I see kittens all the time, I have this idea. And it's such that when we see kittens on the internet, we have this enormous, it accesses all those things. So the kitten model has one aspect as sort of a peek, poke. I was just trying to think in terms of computer memory. It's called, I'm trying to remember about computer memory. There's a reference term. So rather than the data, it refers to the actual data. So it allows us to manipulate it in thought. So the science goes in the word that we have a abstract model, which is like the word kitten, or something which is abstract, which you think about it. You can have a physical model, which is like something which weighs something, like a stuffed toy cat, or a picture. It's a physical model. It's actually physically there. And then there's a mathematical model. And a mathematical model really should be in the aspect of physical models, but it's sort of in between, physical and abstract. It's sort of in between the two, because a physical model you can actually pick up and do things with it. You can sort of cuddle the fake kitten, or you can squash it if you want to. If you want to squash a kitten and stuff like that. You can actually do things to it, and actually physically, to some degree simulates the actual thought, sort of a degree of simulation power. Now, maths has got the degree of actual simulation power, so I can have a model for a kitten. So this is a series of mathematical concepts now that would produce the number of times a day, say kitten meows, something along those lines, some sort of formula. So these are all abstract things that we can attribute to the actual object kitten. So the abstract symbols which I write down are just mathematical concepts. The words are just sounds. The material is just material. It is us. It requires humans in the loop to actually say that group of materials looks like a kitten. That mathematical models gives the same answer for the number of meows as if I actually had the cat there and listened to it over a day. Or the word kitten has the same effect as actually seeing a kitten. If I say kitten, it comes into it. So you've got all those imagination aspects of it. Now, what has happened a little bit is that because we use models so intensely in society have become taboo or sacrosanct. So if a police officer pulled you up and you just say, well, you're just a model of a police officer, no, that's not. This is if you're driving a car, it's a real car, a real car, but you can say you've just modelled my speed. And all that type of stuff. It's taken there. For justifiably, we have actually adopted taking models verbatim more seriously. Now, you can imagine that when someone puts a crown on their head, that is sort of like a modelling process. That's actually that's somewhere between an actual model and the actual real thing, so to speak. But it's a way of communicating that this is that person is a king, and that king therefore uses the model to exert power. So it's really thoroughly in. It's not surprising that when we teach people, we want to teach them the meaningful stuff. The model stuff is something you only get afterwards. So say if you've got a 3-year-old or a 5-year-old and you teach them about toys, well, toys for instance are a model of it, that there's a full understanding, but the understanding gradually comes, so they realise eventually their teddy bear, so my teddy bear still speaks to me, but their teddy bear can't speak, and they put it in the closet. So there's this realisation between models and the actual world. And I find it sort of interesting. Is there a test that you can put on something which says it's a model? A test you put on something which says it's not real. Sorry, it is actually the real thing and not a model. But practically, in terms of process thinking, it's pretty much the same thing. And so there's this emergence of society as we mature, grow up, understanding models, and there's an emergence in individuals as they start to realize what's a model and stuff like that, but there's still this taking on that their teddy bear might actually speak. And so we've had a series of people who've come up with an idea, a model, and it's been a divine belief. So Christianity is, with the Christ and the story there, it's basically a model was revealed of good and evil, heaven and hell, judgment and a process. It is essentially a model, and we have these things, and this is of course complex, that people at a certain stage really needed relics. They actually needed miracles. They needed the true cross and stuff like that. Whereas you've got lots of symbols of non-true crosses which were equally as sacred, and so the society grew up with the technology at the time. So you've got models and word of mouth, and the maturity at the time. So it's like a triangle, if you can imagine those particular concepts. And the last video I did give was on Dante's Divine Comedy, with Dante's Inferno being one of them, and he took the religious model and some model of the classics and some other ideas, and fused it together with geometry to produce a structured world, which actually was a sort of ancient world 2.0. 1.0 was Aristotle's spheres. So Aristotle believed that the planets were circling the Earth, and they were circling the Earth by mechanical spheres, crystal spheres, which were going around the place. And Dante improved upon that and said, look, there's actually spheres inside the Earth, circles of hell, and then going down to that, there's to get that going, there has to be the waste product, the spoils from digging out the centre of the Earth to create the spheres, and that extra Earth is Australia, or is, in his view, purgatory, a big southern land where things are imperfect, ideas are improved from purgatory. So he had this idea, and this idea really met with a new technology of printing. So his poem was printed and read and disseminated and it was a conglomeration of different viewpoints coming together. So this was definitely a model. Now we come up to what I believe, which I would say the ancient world 3.0, Aristotle 3.0, which would be the Bohr's theory of the atom. The Bohr's theory of the atom also has concentric spheres, and it also has imaginary magic holding things up, and it's also got an organisation, a social organisation around it, which is supported. So teachers teach it, people believe it, people get upset, similar to the way that the church got upset when something is wrong. And that model's gone so far, and it's been very successful because it's gone into textbooks, the printing textbooks. The next model up, which is not Aristotle 3.0, it's actual quantum mechanics, is another model. And my sort of theory is looking at Dante and looking at the way the models have come along, that the way that gets up is being printed in digital form. That is, our printing presses are now printing circuits, and we're now powering up circuits and connecting it together. Rather than booksellers, we've got optical fibres connecting places together, putting it together, and there's got to be a new form of intelligence to interact with the ape that's come up to understand it and to explain it. So my belief is that the next degree of teaching quantum mechanics will require social robots to actually circumvent the Aristotle 3.0, which is the Bohr atom, and to come across. And so that's just the area of it. But then also looking at the way that Dante produced a model of his Inferno. Along the way, people produced different models. Galileo produced his model of Venetian Arsenal, this heavy engineering pieces with people walking around in hard hats, sort of Renaissance hard hats, lambering things, and everyone was serious and everyone took it. And then we've had sort of other models, like the models of the Royal Society, universities and stuff like that. And these are obviously do not impact the actual Royal Society. It does not change the veracity of information, or a university doesn't change the veracity of the information. It is a context with which we interface, sort of like a coupling of an antenna. We've got some knowledge. We've got all the knowledge along here. How is it put in a frequency which I can understand? And so these are very much models, and people have taken them seriously and gone into them. So you've got these two different models going forward, and they're not necessarily talking to each other. You've got the educational model, you've got the university model coming up, and it's all been fed by textbooks and stuff like that. Where quantum mechanics really needs to be taught, I believe, by social robots, and with the silicon simulations and expert analysis, which can actually cut through the standard explainer, which is someone who hasn't studied it, studies the teaching degree, opens a book and finds a paragraph, goes down to a paragraph that they understand, and reads that and transfers it across, along with the learning they've had before. So this is very much learning previously has been going forward. People at the moment haven't had a Dante's Inferno, Dante's Hell story to actually see these individual groups, the universities, the people going and all coming together to conceive it in one space. They haven't done that. But that being said, there's some preliminary structures before we get into social robots. We need fragmented knowledge, and I think we are getting fragmented knowledge in YouTube and TikTok. This is people producing little fragments of knowledge, and we're beginning to harvest them. We're harvesting them through a fairly dumb engine, which is it's looking at how much we click, but rather than social robots will harvest the information given a much more intense understanding of how we've answered questions, what we understand. So it'll be a much more intelligent way forward. However, that being said, you need a space to actually put ideas together. That's what I'm going to be doing, is producing very short clips, which are a prototype. So a prototype is prototypes are models of the idea, and you can remove them. So they're the actual ideas, but they're surrounded by model concepts like the name and what it's about. And if I give an idea and someone has a better way of saying it, you can take that down and place a better one up. Then your robot can actually string these ideas together to come up. That being said, there's some basic things, given that you understand that it's a bit of a shambles the way things are taught. Comes the idea of scale, because the scale of things, the femtometer to the universe, and that's 10 to the 36 difference between a femtometer and a universe. There's lots of different grades of physics in there, and a lot of people tend to not understand that they can teach very well our scale one with the models. Other things else, their models that they use, which have been so successful, doesn't go across. They haven't really, I believe this teachers haven't really understood the scale idea. At what point do you talk about quantum wave functions? What point in time do you talk about dark energy? What point in time do you talk about the closed universe? What point in time do you talk about entropy and boiling water? There's different points to it. So there's a strict way of, we need to develop a way we discuss scales in the way of accessing the correct model. And the way that we discuss scales itself has a whole series of model aspects of it. We've got the abstract, the word scale, 1 to a trillion. We've got the mathematical division of it, and we've actually got the symbol of a scale that you draw on a diagram. And when I'm trying to put this tableau together of this generic scale, what is the basic scale that we could lock upon to sort all this out? So at the moment, we have an uneducated person coming in, picking a scale up, and it all gets into a mess in the minds of students. What we really need is this fundamental set of, I think I've gone for 5 scales. That's a trillion to 1, 1 to 1, 1 to a trillion, 1 to a trillion trillion, and 1 to a million trillion trillion. And I'll be coming up to now the condensed model for describing it, how you describe those scales, and the fact that there's a basic unit that we have, which is a thousandth of it. So I'm going to draw a picture. It's not going to be a meter, a 1 to 1. It's not going to be a meter. It's going to be a millimeter. It's going to be the unit. If I draw a picometer, which is a trillion to 1, the actual thing which I can draw very easily is a femtometer. So there's a whole series of ideas of understanding how you deal with models, which is an entry point to actually understanding how you deal with scales. And my idea for scales is to understand it's a model and understand how you go through and describe these 5 scales as IST -1, IST 0, IST 1, IST 2, IST 2.0. International scale trillion to the -1. International scale trillion to the 0. So the international scale IST 0, it's an exact scale. But the problem is with this digital medium on my phone or on a data projector, we can expand and contract anything. So you need to have a witness scale to expand and contract, and for that to be a standard unit. So the IST will tell you what that number is. So in all diagrams that we have said that the Australian drafting standard that we have, if I have a scale and the number 3 next to it, it is by international convention 3 millimeters. I don't have to write millimeters next to it, or I don't have to put the feet and the inches there. That's the way we've simplified it. So, but for IST -1, I have a little unit. That unit is definition 1, means 1 femtometer. I don't have to write femtometers against it. And if I expand or contract it, the witness is there. And so indeed, I find in order to start to build some of the machinery around these pools of ideas for eventually the social robots to come forward, I need to get some understanding, a model convention and a naming convention for scales, and try and discuss it there. And very much at the final point is that we've got that aspect of models, also the social aspects of models, in terms of that we've had Dante's Hell, Galileo's Venetian Arsenal, the Royal Society, universities. But what's going to be the next social structure? So that's something which I'm thinking about, working about. What is the next social structure which we says that has basically a bedtime story about it? You can't suddenly say here Mary or Sarah or Michael, whoever you're reading your story to, at bedtime, here is a picture of a, say, virus. Let me tell you about Edward Jenner and what people. There's an entire story and the fairy story aspect to it. That's where and a fairy story is again another model. It's got to have those aspects to it. So there's a bit of work to do about this. Thanks for watching.